Good afternoon, my name is Alejandro Alvarez, we are Team 15, and we would like to present to you our LED solar panel project today. Let's get started. The topics that we would like to present to you today is the project description to see how our design will work for this project, a form of marketability which will try to bring you to an understanding as of where this project will be going towards, then our problem statement and objectives to see what they are and what our objectives will be with this project. The intended users and uses to show what kind of demographic this kind of project is really looking towards. Then the background to show the comparisons between our project and already designs that are already out there for this kind of solution. Then the intellectual property to see how we will be avoiding infringement. Then the ethical considerations to see what our dilemma is with this project and what solutions we will be presenting for it. Then the concept development to see what our options will be for this said project and how we'll be presenting them. Then the conclusion to bring together all the concepts that we have presented today. So let's get started. For the project description, for our project, we're trying to show a new solution when it comes to gaining power for solar panels during nighttime. Our idea for this would be to have a kind of awning system with LEDs that would be a cover for it to reflect the light from these LEDs to gain power from it, for the solar panel to gain power from the LEDs. The way that this system would function is that there would be an awning that would be automatic by means of having it being programmed from the use of Arduino to have it open during certain time frames during the nighttime and then have it close during a certain time frame during the daytime. Another alternative way that this process could happen too is having certain kinds of sensors that would detect whether it is nighttime for it to, of course, open or daytime for it to close. For our marketability, our first market we want to go towards is individuals who need constant energy for certain conditions when it comes to certain weather patterns happening or just even during nighttime. Another one would be companies that would be looking for solutions to have constant energy usage no matter the case of what sort of conditions are happening. And then our last market group that we want to go towards is other facilities that want to readapt their already pre-existing solar panel technology to add our idea to theirs. Then for our problem statement, the main problem that we're trying to solve is that solar panels do not get any form of energy during nighttime and also certain kinds of weather conditions that would also do the same. Another issue that would come up is that without solar panels, there would be certain kinds of advantages that would not sort of happen due to the loss of solar panels during nighttime, such as having renewable energy, dealing with less cost of electricity, and it would also have very low maintenance costs to deal with. And our main objectives for our panel would be as follows: being able to have LED power during nighttime and automatic retractable awning. It will be cost effective and safe for certain environments. And the LEDs would be off during the daytime, and on at the nighttime. And then the LEDs would have a form of a rechargeable battery for its use. And now my group member Etaine will be talking about the intended users and uses of our project.
Hello everyone, my name is Castaneda, Miranda, and I'll be continuing on from this portion of the presentation. Now, for the purpose of having a definite vision of what will go on in the development of our project, we need to view our product in a more relative situation. So we need to really define who are intended users and our intended use for the product. Now, our intended users are homeowners, business owners, individuals and groups who are really looking to go green or already currently green. Now, in this case, solar panels are very expensive, and most of the time they're not efficient at night in comparison to day. Our product is a solar panel alternative where not only is it cost effective, but it will also work in non-ideal weather conditions, such as nighttime, cloudy weather, rainy weather, and so on. Now, for the purpose of the background, we really want to explore past projects, ideas, products, and really understand their process of implementation and their successes and failures to get to the final design that they are. Right now, there are no solar panels that are powered by LEDs, so instead we'll be looking at 3 projects that kind of encompass the idea of what we want to incorporate in our final design. The first product is the Expand Solar Awning created by Exponent Power. Expand Solar Awning is created for RVs, but this important part of the product is that it's not like a standard awning and where it's made out of fabric. It's entirely made out of solar panels. As of right now, Expanse is one of the world's only commercially available solar awning. What really makes it special is its key technologies of glass-based solar panels, high-efficiency bifacial solar cells, bypass diodes, and motion sensors. And with Exponent's power patent design, they're really able to make a really effective solar panel awning, which not only creates energy from the top, but it can also create energy from the bottom surface of the solar panel. Now, in our case, we are not looking to develop a solar awning, but we do want to take in consideration the components and the thought process that they have put into this awning so that we can also possibly implement those ideas or thought processes into our design. The next product we want to take a look at is Solux Window Awning. Solux is a branch company of Carefree of Colorado, which is also a Scott Fetzer company. Solux was created back in 2017 to address some lack of innovation in the residential market, especially within window awnings. Solux prides itself in having the smartest window awnings out there, and you can really see that in the key technologies that it presents, such as the Bluetooth module, motion sensor, the position sensor, the temperature sensor, the rechargeable battery pack, and the integrated solar panel. The group really wanted to take a look at this solar awning, considering that it's one of the best solar awnings out there in the market. This solar awning is embedded with technology. With all the sensors, it's able to retract and extend whenever needed, practically making the solar awning completely autonomous without the user input. However, with the Bluetooth module, the user is able to also control the awning and set scheduled times to retract and extend whenever needed on a timely schedule. The last product we want to take a look at is Somfy LED Awning Lighting Kit. In comparison to the other products, this is more of an accessory to a product, specifically to Somfy's automatic retractable awnings. However, this lighting kit can be put on other awnings depending on the specifications. The awning lighting kit is simplistic in design and simplistic in its technology as well. As you can see, it mainly consists of the radio technology Somfy receiver, the 4 LED bar, 12 volt with adhesive, the Bluetooth module, and the Wi-Fi module. The main component in this product is the RTS receiver, which is Somfy's patent design and exclusive control platform. This product gives our group another perspective in how we can implement LED lighting into the back of an awning. The next section we want to take a look into is intellectual property. Intellectual property is a crucial part of the process in researching and developing and design. Intellectual property is necessary in terms of establishing the sole creator and proprietor of an invention regarding artistic and literary works such as designs, symbols, images, and names. To protect the intellectual property of our project, our group has documented the detailed concepts and original content. To finalize the process, our group has also conducted extensive online research for relevant patents through Google Patents. The first Google patent that we'll be looking through today is LED street lamp with power generation system. This patent number can be seen here, and the inventor of the patent is Sekwon Chan. Now, this patent would have a power generation system using the streetlight lamp with its diodes from its LEDs. The main feature of this patent would be having different kinds of power generation, such as pressure, and that would also be connected to the central controller. These different power generations include solar, thermal, and electricity, and that would go into the LEDs, to the LED portion of the street lamp, and other devices would then take on the electrical engine energy. Now, there are 20 claims on this filed patent, only of which one claim kind of correlates with the idea of our project. But fortunately for us, there is little to no similarity, with only the same involvement of using LEDs for power usage for a certain component. However, there would be a huge addition with our project, which is the need of an awning to have a cover filled with LEDs to give off their light to power the silicon power cells. Now the second patent that we'll be looking at today is the solar powered light pole and LED light fixture. The patent number can be seen here, and Seth Jameson is the inventor of this patent. The way this invention works is through a pole-mounted lighting that is being powered through photovoltaic solar panels that are then placed on a storage device and pole. For the photovoltaic panel, they're using photovoltaic laminate and LEDs to form light over a series of nights under conditions that the sunlight is obscured. There are about 27 claims that have been shown for this file patent, and claims 1 and 4 kind of pertain in the realm of where our project is going to be, in which they incorporate light compromising and energy storage device being connected to a panel where sunlight meets the photovoltaic panel and is then stored in the device. Other than that, there are really no similarities to our project to the following claim other than the usage of solar panels and LEDs being used on multiple rows and columns on the outer surface with batteries. Now the third patent that we'll be looking at is a solar-powered LED illuminated alphanumeric display. The patent number could be seen here, and on our research we really couldn't find a sole creator for this patent. This patent involves a display that would have solar panels on the top and an acrylic panel that would have letters etched on the bottom, which would include a rechargeable battery with a series of LEDs, and that would be above the acrylic panel to light the display. This invention would also involve a solar panel display that would emit light diodes that would only need certain low power requirements. There are about 14 claims settled for this patent. 2 have shown that they can coincide with our idea, with the talk of having a rechargeable battery being mounted within the house, and that would then power the solar panel to recharge the battery, which is kind of the same concept that we have with having the LEDs to give more power to the solar panel. For this patent, we would have liked to have some similarities with the involvement of the battery power, since our LEDs would need to get power from these batteries. However, for our project compared to this patent, there would be a different kind of component that would then be integrated differently than display with a solar panel on it. My team member will continue on with the rest of the portion of this presentation. Thank you.
My name is Anthony Osorio. I'm the Senior Design Team Leader. I'll be speaking on ethical considerations, concept development, and the conclusion. This is from the IEEE Code of Conduct. This guideline summarizes the most with our project. At least summarizes the goal of our project, and also summarizes what we do as engineers, our obligations to our profession, and we had to uphold to the world with the utmost integrity and honesty. And a concern that we faced was the manufacturing process and the disposal of solar panels, because the manufacturing process involves the panels are composed of cadmium, which is toxic, and if it seeps into the soil, is actually harmful to the environment. And the disposal of solar panels, there's no mandate on it at the moment, but they're being tossed into landfills, so it will produce a lot of solar waste in the future. And the solution that we have is to notify the public, the intended users, that there will be advancement and research in terms of the manufacturing and the end-of-life process in order to improve energy of conservation. The Good Life is a TED Talk by Sebastian Deterning, and our vision of what the project would be is we want our main focus to be that our product will be fully operational in terms of power efficiency, and it will be a constant source of reliability and comfortability for the customer, and they will never have to worry if they're under circumstances where they need to have constant energy, either natural disasters or moments where there's little to no sunshine. For the concept development, we had 2 options. Option 1 was automated awning, which should be programmed with intelligence, which would be through Arduino, the LED panels, and then the 220-watt solar panel. For option 2, we had the manual awning, the LED awning kit, and the 250-watt solar panel. We went with option 1. We felt that was the best choice in terms of cost and energy efficiency. This is the system overview for the option 1. This is the automated awning, which you'll be able to retract on and off through the usage of Arduino. These are the sensors and components that it consists of. It will also have a light sensor that will be able to detect dust particles at dawn. And we will find a way to implement the LED panel onto the awning. And this is the 220 watt solar panel that would be powering the whole product. We felt the LED panel was better in terms of flexibility, cost, installation cost, also has less heat dissipation, and also has a better ability to, as far as programming for it. And also, automated awning is better versus the manual one, because the manual one, individuals can forget to retract it. You have to manually do it yourself. So, in conclusions, we were able to filter out the potential alternatives, and we came to the conclusion that the automated awning with LED panels and a 220 watt would be the best experience in terms of energy efficiency and cost, and we feel that it's going to be innovative and revolutionary in terms of the service it'd be able to provide for companies and individuals that are looking to have a constant source of power throughout conditions of little to no sunshine.